this is x equal to 2 plus 2y. You put here, so minus 2 into x equal to 2 plus 2y plus y equal to 2, that is minus 4 minus 4y plus y equal to 2, that is minus 3y. This is 6 minus 4 here, this is 6, so y equal to minus 2, y equal to minus 2, and from here x equal to 80, 2 plus 2 into minus 2, so minus 2, this becomes minus 2. So x comma y, we get minus 2 comma minus 2. So minus 2 comma minus 2 is the critical point. So this is the critical point. So we get only one critical point. Now we find f xx. So here f x we get this. So f xx will be minus 2. F xy will be here. This is 1. And f yy we will get from here yy. This is minus 2. Now we have to find f xx into f yy minus f xy square. That is minus 2 xx minus 2 yy minus this is 1 square. That is 4 minus 1. That is 3. So greater than 0. So this quantity is greater than 0. Also, if you put the value at minus 2, this is also 3, which is greater than 0. So therefore, this point may be point of maximum or point of minimum. So on which if xx on the value xx at xx fxx minus at the point minus 2, this is minus 2, which is less than 0. So if xx is minus 2, that is less than 0 at this point. So this will imply this point minus less than, so this point is point of maximum or local maximum, point of local maximum. So this is the point of local maxima, and the local maxima point will be, so if you put x minus 2, y minus 2, you will get the maximum value of f, which will be, you can put the value here. So minus 2, this will be 4, this will be minus 4, this will be minus 4, minus 2, this will be plus 4, this will be also plus 4, this will be plus 4. So minus minus plus plus 4, this will be 8. So the maximum value of this function is 8 and the point of maximum is minus 2. This is the problem. So you have to solve in this way. First you have to find f(x), fy more than equal to 0. Solve this equation. You will get x comma y, which will be the critical point, and you have to find fxx, fxy, fy. In this case all are constants. So therefore at this critical point also the value will be minus 2, 1, minus 2. So therefore we have to find the quantity this. So its value is 3, which is greater than 0. So therefore there is two cases. You have to look at fxx at this point. So this is minus 2, which is less than 0. So this is greater than 0 and this is minus less than 0. So therefore we can say this point is maximum. If this is less than 0, then from here you can conclude that this point is saddle point. Okay?